All right. This is from our Chapter 6 Calculus assessment. Several of you wanted to retake it and haven't had time to come in for tutorials. So this video will be going over everything you did or didn't want to know about derivatives from the test. Okay, so we have a graph going across the screen. Remember, we're talking about the tangent lines. The tangent lines are those lines that touch at each of those at just one point. Think about it as that roller coaster ride along the graph. So at A, our line of sight on the roller coaster ride would be like that. At B, it would be like that. C, D, straight across, and E would be up here. So, local maximum points would be those tops of a hill on a roller coaster before you go back down the hill. So a local maximum point would be B. This would be a maximum. A local minimum would be down here. Now, the gradient, the slope of that tangent line at each of those points is 0. Now, what's interesting is, at D, the gradient is 0, but this one isn't really a maximum because he doesn't go back down the hill, and it's not a minimum because we didn't come from the top. So, let's go through and answer these. A was the local maximum point. Well, there's your maximum. Minimum point would be C. The gradient is 0, but it's not the top of a hill or the bottom of a valley. At D, it kind of stalls out and then continues up. The gradient of the tangent to the curve is positive. So where are my slopes positive? Well, at A, and then again at E. And notice that one did say 2 points. Where's the gradient of the tangent positive and f of x equals 0? So in other words, where do I have a y value of 0? I don't. That one is supposed to say when x equals 0. Oh, there's a typo on that problem. I apologize. Because when do the y values equal 0? There are none. Okay? Number 2. Consider the function 2x cubed minus 3x squared minus 12x plus 5. Find f prime. That means to find the derivative. And we're going to use that power rule. Power rule says the exponent comes down and multiplies with the coefficient, and then you drop your exponent down 1 notch. So 3 times 2 is going to give me 6x. And then I'm going to go to squared because a 3 drops down to a 2. Minus 3x squared. So 2 times a negative 3 would be a negative 6x to the 1 because the 2 would drop down 1. Negative 12x to the 1. So that's going to be a negative 12x to the 0 when I bring it down a notch. Find the gradient of the curve when x is 3. Remember, your derivative is finding those slopes as you go along the curve. So you're just going to plug in 3 into that function. And I apologize that my hand looks purple. It's because the paper is a bright gold. And so as I'm writing on it, my hand looks purple. 6 times 3 squared minus 6 times 3 minus 12. And we get a 24. In other words, the slope when x is 3 is 24. It's very, very positive. So that'd be very, very steep on the graph. Find the x-coordinates of the points on the curve when the gradient is negative 12. So now they're giving us the gradient, and we're trying to find the x value that gives it. So you're working backwards. You're going to take that derivative and set it equal to negative 12. All right, so I'm going to add 12 over here, and I get 6x squared minus 6x equals 0. I'm going to factor out 6x. I get x minus 1. Set each factor equal to 0. 6x equals 0 only when x is 0. X minus 1 equals 0 when x is 1. Those are the x coordinates that give me a gradient equal to negative 12. Calculate the x coordinates of the local maximum and minimum points. Well, maximums and minimums have a gradient of 0. We just looked at that. So when is our gradient 0? So when does 6x squared minus 6x minus 12 equal 0? Well, to help myself out, let's divide everything by 6. X squared minus x minus 2 equals 0. Ooh, that's factorable. That'd be x minus 2 times x plus 1 equals 0. That's x equals 2 and x equals negative 1. Now, which one is going to be a minimum? Well, you could use your calculator to help you figure that out. If I put in the original function, and look at my graph, there's the maximum, there's the minimum. So the maximum is occurring at negative 1, and that minimum is occurring when x is 2. You can also tell that by your table. I'm going to go to the table, set it up, and start it back at 0. When x is 2, I'm at my minimum of negative 15. Remember, the other way you could find your maximum and minimum points is while you're at your graph, maximum and minimum are options under your calculate menu. So looking back at the graph, for what values of x is our function increasing? So notice it's increasing. We're going up, and over here we're going up. So the x values that were less than negative 1 were increasing. And then over here on the right side of the graph, when we're greater than 2, we're also increasing. That's all it meant. Next problem. For what values is f prime equal to 0? In other words, when is the derivative 0? So those would be maximum points. So when x is 3. Minimum points when x is 5. And you could have done a range here, and I also accepted just 7. But some people put 6.8 to 7.3, and that's fine as well. For what range of values is the derivative negative? And that's when the roller coaster is going downhill. So that'd be this section of the graph. So that would be when you are between 3 and 5. Number 4. Here's our function. Calculate the value of f of x, in other words, our y value, when x is 1. So f of 1 is finding the y coordinate when x is 1. So 3 divided by 1 squared is going to be 3, plus 1 is 4, minus 4 is 0. So we have the point 1, 0. That's a point on this function. Now we're supposed to take the derivative of f of x. It really helps to rewrite it. What's a way to rewrite 3 over x squared? Well, that's really 3 times x to the negative 2. Now it's a lot easier to take the derivative of. The power rule says I'm going to take the exponent times the coefficient. So I'm going to get negative 6 and subtract 1 from my exponent. If I subtract 1 from a negative 2, I get a negative 3. This is really a 1. 1 times 1 is 1. When it drops, it goes away. Another way to write this is negative 6 over x cubed plus 1. Find f prime of 1. So remember, the derivative is that gradient, the slope of the tangent line going around the curve. So when we find f prime of 1, we're finding that slope of the tangent line. Negative 6 divided by 1 is going to be negative 6 plus 1 is going to give me a negative 5. That is the slope of the tangent to the curve when x is 1. Or we could say at the point 1, 0. Because we actually know the coordinates of that point. Find the equation of the tangent to the curve at the point where x is 1. So here's the point. We know the slope. This is an x value, the x value of a point. This is the y value of that point. 0 equals negative 5 times the x. We're trying to find the y-intercept of that equation. So this is going to be negative 5. We'll add it to the other side and we get b is 5. Now that is not where we stop. The equation of that line is negative 5x plus 5. Determine the x-coordinate of the point where the gradient of the curve is 0. So let's go back. The gradient of the curve is this one. We want to find out when negative 6 over x cubed plus 1 equals 0. So I'm going to cross multiply. It's going to give me negative 6 equals negative x cubed. In other words, x cubed equals 6. So the cube root of 6 is 1.82. I wish that one had been prettier numbers. I did get that from a test. Those were kind of ugly numbers, but still doable. The last one tricked a lot of people up. A lot of this you could have done with your calculator. We have a football being kicked from a point A, 0, when A is between 0 and 10 on the ground, towards a goal to the right. And here's the graph it takes. So I'm going to start by plugging in that function into my calculator. It's negative 0.021 x squared plus 1.245 x minus 6.01. And if we look at the table, or the graph, you can see right there is about our x, our A, that point where it's crossing through the ground. Now if I look at the table, I can tell it's between 5 and 6. That would be considered a 0 point because the y value is 0 at that point. Left bound means make sure my little spider is to the left of that point. Right bound means go to the right of it and press enter. It tells me that that 0, or that x-coordinate, is the point 5.301, or 5.3. Now, I should have changed my window a little bit because it said to make sure that that value was between 0 and 10. You could have done a little bit of an estimate. Find dy dx. That's the derivative. Everybody should have gotten this one right. All you're doing is applying the power rule. Use your answer to part B to calculate the horizontal distance the ball has traveled when its height is a maximum. Okay, so when are we at our horizontal distance to get to that height? I'm going to change my window a little bit. Let's see if I can see where that ball is reaching its highest point. Almost there. I need to get this a little higher too. So I'm going to change that. And I'm just guessing. I want to see if I can see the whole thing. I can't. I can see where the ball got kicked from the ground, went up in the air, and then came back down. I want to know that maximum point. Left bound, right bound, and go for it. The maximum is at 29.6 for the x value, and the vertical height is at 12.4. The goalposts are 35 meters from the point where the ball is kicked. It was kicked 5.3 meters from the origin. So, we want to know what the height is when x is 40.3. You can actually do that on your trace. If you hit trace, you can type in any x value you want, and it'll give you the y value that goes with it. When x is 40.3, y is 10.06. At what height does the ball pass over the goalpost? At 10.1 meters. Now, for those of you taking the retest, it is shorter. It does not have one of these problems that got everybody really confused. It is your basic derivatives, finding the tangent to the curve, all the stuff that we practiced a whole bunch.